And let us see what is a power generator. Electromagnetic induction. There's a principle called electromagnetic induction. A power can be induced by this electromagnetic force. Michael Faraday, an English physicist, a scientist in physics, is supposed to have studied the generation of electric current using magnetic field and a conductor. When a conductor is said to move inside a magnetic field, or a magnetic field is said to be changing around a conductor, electric current is induced in the conductor. This is just opposite to the exertion of force by a current carrying conductor inside a magnetic field. In other words, when a conductor is brought in relative motion vis-a-vis a magnetic field, a potential difference is induced in it. This is known as electromagnetic induction. Electromagnetic induction. Electromagnetic induction can be explained with the help of Fleming's right hand rule. We hold the hand like this. The motion is in this direction, the field in this direction, and the current. They are in mutually perpendicular directions. If the right hand is stretched in a way that index finger, the pointing finger, the middle finger and the thumb are mutually perpendicular in directions, then the thumb shows the direction of the movement of the conductor. Index finger shows the direction of the magnetic field, and the middle finger shows the direction of the induced current in the conductor. And the directions of movement of a conductor, magnetic field and induced current can be compared to the three mutually perpendicular axes. That is X, Y, and Z axis. The mutually perpendicular directions also point to an important fact that when the magnetic field and movement of a conductor are perpendicular, the magnitude of induced currents would be the maximum. So two principles we studied. Electromagnetic induction is used in conversion of kinetic energy into electrical energy. Kinesis is converted to electric force. The structure of electrogenerator is similar to that of an electric motor, and in the case of an electric generator, a rectangular armature is placed within the magnetic field of a permanent magnet. The armature is attached to a wire and is positioned in a way that it can move around an axle. When the armature moves within the magnetic field, an electric current is induced in the coils and the wires. And you can see this picture. This is a turbine used in generating stations. A water current in hydroelectric generating stations. A water is made to fall forcefully onto the fins of the turbine. This causes the kinesis of the turbine fins or the whole axle. And on the axles is placed a coil wound around in an armature, and it's moving in a magnetic field, and the water causes the turbine to rotate in high speeds, generating power. This is the principle by which generator is producing electric energy. The direction of induced current changes when the armature crosses the halfway mark of its rotation. Remember, the direction of induced current changes when the armature crosses halfway mark of its rotation, halfway mark. And the next halfway is this. In a rotation, two hemispheres will be there if it goes round and round. In the first hemisphere, when it enters the second hemisphere, the direction of the current changes. Thus, the direction of current changes once in every rotation. In every single rotation, it changes once. Due to this, the electric generator usually produces alternate current. In short, we call it AC. To convert an AC generator into a DC generator, a split ring commutator is placed. This helps producing direct current, DC. AC and DC current. AC, alternate current. Its abbreviation is AC. Current in which a direction is changed periodically is called alternate current. In India, most of the power generating stations use this principle. DC, direct current. Current that flows in one direction only is called direct current. Electrochemical cells produce direct current. Mostly you can see the cells. They are electrochemical gadgetries. They give you direct current. So this is what we have learned so far. We can recapitulate what are the points we have learned so far. One, we have defined magnet, then current, electromagnetic effect, magnetic field, the properties of magnets, right hand thumb rule or Maxwell corkscrew rule, power generators, types of power, magnetic induction, AC and DC. In a nutshell, this is what we have learned so far. Please remember these points. Try to explain everything. The key points are important. You remember that. Thank you. Generate the power of knowledge. Thank you very much.